Here we go. Now we're recording. Okay, so let's go ahead and open up the file to read it. So scanner reader equals new scanner new file. Import that, and we're going to call it, and the file is pg100.txt. Okay. And scanner, now it's telling me that basically I have an uncaught exception, so I'm just going to say that I'm going to warn anybody who calls the main method that main can throw an exception, rather than trying to do a whole try-catch block. Okay? Because I like my code to be nice and pretty. Okay, next. So let's go ahead and make a map. Map index is equal to new hash map. And I'm going to show you a hash map, then I'm going to show you a tree map. Don't need to use any like index nodes or anything for this. So what we're doing though is we are going to do a count of the strings. So we're going to count up each word, and we're going to count up not how often it appears, but what lines it appears on, right? That was the assignment. Okay, next let's go ahead and read the file. While reader dot has next line. And as I mentioned, I prefer using has next line over has next because depending on how stuff gets read, you can have some stuff left over in the buffer, and that can be really tricky to deal with sometimes. So I like to read the entire line all at once and then figure it out from there. So while it has the next line, string next string line is equal to equal to reader dot next line. Okay, let's go ahead and print that out, right, just to make sure that everything is working. Right, that actually printed out fair. I actually am surprised how fast that printed out, because printing can take a long time. All right, so now let's go ahead, and now that we're printing it, let's go ahead and make a counter. Int line number. Int line num is equal to 0. Line num plus plus. Right, so we'll read every time we read a line, we'll increment line number. And then what we're going to do is, sorry, the laser's making noises. Every time we've done that, we are going to, let's see. Now that we've read the line, we need to split it up. String words is equal to line dot split. I'm going to be right back. I want to make sure laser didn't run out of the house. Nope. That was my wife going outside for a second. All right. So we're going to split the line. And now for string word in words, right, we're going to strip everything apart. We're going to basically strip all the unwanted characters out of it. So word equal to word dot replace all, and anything that is, so I'm creating a regular expression here. Anything that is not, word dot is equal to word dot to lowercase. Anything that is not A to Z, or an apostrophe, or a dash, I'll remove. And now we need to add it to the, we need to add that word to our index. So if index dot contains, so if we do not have the, if we've not seen this word before, then what we need to do is that we need to create a new list for it. So list of integers is equal to, actually I'll show you a different way of doing this. This is actually fairly elegant. So first off, if I haven't seen this word before, I need to create a new association for it. So so what I'll do is I'm going to create that association right now. Index dot put word, and now I got to create a list. So new Okay, if you're wondering what just happened there, I accidentally hit something but basically I was telling Java, and I didn't mean to tell it this, that, I want to, make a list class on the fly. Which I don't want to do. So you can create new interface. You can implement interfaces on the fly like that. So new ArrayList. I'm just going to create that on the fly. So notice that basically I'm just creating I'm creating a word and a new empty list associated with that word. Okay, now regardless of what happens, what I'm going to do is I'm going to do index.get word, which gets the list associated with that word, and I'm going to add the line number to that. Make sense?
Yeah.
Okay. And so that actually handles all the cases right there, because if the list isn't already there, I make the association, and then I get the association and add the line number to that. That's all I need to do. So it's a while loop.
Although it did actually ask for how many times it showed up.
Yeah, that's easy enough to do. I just get the size. So system.out.print line index. Let's see what prints out. Something probably huge. There we go. It says a blank occurs this many times. So we need to actually do some parsing here. Okay, so for,
I think that was actually just the back half of the line.
Yeah, for string word in index dot contains key. I'm sorry, not contains key. In index dot key set. So in other words, we can iterate through all the keys in the key set. Sout word So, oh yeah, this is just going to be numbers. Wait, no, it's gonna be the association of those. Print out word. Actually, we can do print out index.get index dot. Let's see, is there a nah? We'll just do word word plus space plus index dot get word. No need to overcomplicate this. There we go. And now notice that the issue here with this is that our index is out of order, right? It's kind of totally random, right?
Mm-hmm.
And that's because we used the hash map over here. Remember,
the other issue is that it counts words that start with a single quote as a different word.
Yeah, but I'm not going to worry about that for right now. That can be handled some other point, and it's not the important point I'm trying to make here. So this hash map, right, it runs super fast. Each of the operations I'm doing here, to put and to get, that's a constant time operation, mostly. Okay? These are constant time operations. They don't take long. To print out everything in here took me of n time to do the get method, right? So it's not too bad. However, there is a the sacrifice for speed is that I'm going to be wasting a bunch of memory intentionally, right? So that I can have a bunch of empty space for my for doing all these operations. Have I used the parking lot metaphor in my videos?
Yes.
Mm-hmm. Good. Right. It's like, right, in order to make sure that I can park my car, I make sure that there's going to be half the spaces open at all points so that I can find a space very quickly. Okay? So what if you want to keep things sorted, though? Well, if you want to keep those things, if you really do care about order, you can use a tree instead. And in that case, we use something called a tree map. Now, a tree map does all the same operations as a map does. Takes a little bit longer, but it cares about order. If the things are comparable, it will keep them in order. See how this has been kept in alphabetical order?
Yep.
So you can use either now the disadvantage of a tree map is that all the operations, it's a balanced binary search tree, guaranteed to be balanced. So every operation you're doing takes log n time. So printing everything out like this takes n log n time because it takes O of n time to iterate through n items because it has a nice iterator. But then I had this get, which gets the value, which means it has to traverse to there and find the appropriate node and get it, which takes log n time. So n log n there. To build the tree, it also takes n log n time. But n log n versus n, really not too bad of a difference. N log n is a great time. N log n is a fantastic runtime. And it's often the best you can do. It's the best we've got for sorting with a single thread. So, now speaking of sorting, right? Again, you've got the